Hi, my name is Mary, and I'd like to present my Project 2. This Project 2 builds on the Project 1 of CSCE 647. So I'll go over Project 1 a little bit and then point out what's new in this version. So just like Project 1, you can create a normal map on the left-hand side of the image. And this is based in formation curves between the corners, and Kuhn's patch does the interpolation of the normal and of the positions. Since this is a triangular mesh, it's composed of triangles, and the Kuhn's patch calculates the position of each triangle. So you can create some fun shapes. The left-hand side creates the normal, and the right-hand side makes the rendered image. You can also modify the position of the light. So on the right-hand side, I'm using a caustic that is projected onto the background and a diffuse light onto the surface. The caustic is new for this project. That's been updated, as well as the camera can now pan, so to create a 3D representation of this surface. So using the WASD keys, you can pan to create different views of the scene. And in the future, I'll add a UI option to create an image behind the surface instead of just a gray background, as well as a texture map onto the surface so that it can look like a different material. But yep, added the panning. There's also a little bit of depth that's been added to the image. This isn't the best math yet, or this isn't, this will be improved, the depth calculations. But the user can pan left, right, tilts the camera up, tilt the camera down, as well as modify the distance between the surface and the ground. So with the slider, you can move the surface further away or closer to the ground, as well as change the index of refraction. So since this is caustic, the index of the surface is projected on, or bends the light to project light onto the background. So put that a little bit closer, sharpen up the index. Yeah, so in addition to showing the 3D representation and adding distance and index, you can modify the color of the surface with this slider. As an Aggie, I like to choose 8000, make it a little bit darker, get a nice maroon. As well as the surface color, you can modify the light color with this slider. So you can choose like a warm, let's go warm yellow. And that affects how the diffuse shading looks onto the surface. As well as modifying the surface color where the light is touching, you can see that the caustic has also been updated based on how the light is. So where the light hits the ground, you can see the color. So the yellow is on the ground. Where the light doesn't hit or is refracted away, you get the inverse color. Yeah. So that's the UI. Again, there are quite a few improvements that I think that can be made to this this project, including adding the specular highlight, adding shadow, making the depth mapping look better. UI controls for that would be good, as well as having texture mapping and background pictures. I think that would all look good. Let me show you the code for this. So this is the camera controller. So this changes the, based on what the user presses, it changes the position. Actually, let me show you the shader first. So you can see that this uses the camera view projection to warp the position of the image on the vertex shader. And then if I open up the camera, it uses the CG math perspective, and based on where the camera is and where it's pointing to, determines how the image will be projected. The caustic is created by shooting rays on each pixel or each triangle of the background image. It uses it takes thetas from -4 to 4 in both the X and Y direction, shoots a ray to the normal, grabs the normal value that it intersected, that it hit on the map, calculates the value for B based on the eta and A, performs a dot product, scales light, and adds them. So it shows the bending of the light from a ray that's been shot from the ground. On the grid, this is how the depth is currently getting calculated. This math will likely change, but for right now, so I grabbed the origin. So the origin starts at the bottom left-hand corner. It goes up in columns and works its way right. So I grabbed the origin, I grabbed the movement, so how far it's gone away from the origin and in what direction. The normal at the new point. I take a cross product between the movement and the normal, and that gives me the axis of rotation. With that axis, I rotate it 90 degrees so that now instead of the normal pointing out of the surface, it's pointing along the surface. And then I move in that direction as much as that point is moved from the origin. So that's how the depth is calculated, and then I update the depth. Thank you.